Awesome. Thank you so much. Thanks for spending, hopefully wisely, the next 35 minutes with us here in the room. When I started preparing this presentation, I thought maybe 20 slides. I ended up with more than 50. So that's why I thought I will not bore you with 50 slides, because I also want to show you some live stuff. But what I wanted to start with, all of my slides, all of my material, everything I go to today, all the patterns I discuss, there's 2 QR code links on the left side. This gets you to what we call a notebook. So I'm talking a lot about OpenTelemetry today, but I have prepared all of my examples using our product. We have a public available playground tenant in Dynatrace, so the left link gets you to that playground tenant, and you can see all of my queries, all of my patterns. On the right side, this should be the link to the PowerPoint presentation. I do hope this link works, but it's the original, like the direct link. Okay, I will have it later on as well, but just so you know, I will probably not go through all the slides because it's just too much. Before I get started, and I see some thumbs up, yeah, because before I get started, I want to quickly ask one question, because I know observability is a bigger and bigger topic for everyone out there, but I want to understand, how familiar are you with observability? So my first question is, how long have you been using, if at all, distributed traces? Quick show of hands. Never? Who has never used? Okay, 1, 2, 3, 4, 5. Okay. Maybe started in the last year. Awesome. Yeah. About 5 years? Cool. Longer than 5 years? All right. This is when I started distributed tracing. I started 2008, because 2008 is also when I joined Dynatrace as a DevRel. So currently I work as a developer relationships. I'm part of engineering, and my goal has always been to help our global community to figure out what we can do with traces, and obviously with all the other signals of observability as well, metrics, logs, events, and so on. But 2008 was for me a game changer, because 2008 was already the time when we had tools like Dynatrace, New Relic, AppDynamics. I think there was also a product from Wiley, that was later acquired by CA, that already provided automated end-to-end tracing. So if you think it's all new, it's not new. The concept and the technology has been out there, but it was obviously limited to tools that did the automated instrumentation through custom, very specific agents. But what you could already do back then, we could see everything from the browser click all the way through your middleware. I think the presentation we had earlier, before my talk, was around mainframe. So our agents that do instrumentation also instrument the mainframe. Then you're from Commerzbank, right? You also just told me you're using our product. You have probably a big mainframe. So distributed tracing is not new, it has been around for a while. And what I've noticed is there's a lot of common patterns that I have analyzed over the years that showed me how easy it is to fuck up your system. Right? And I'm sorry for using this language, but I wanna explain you and show you things that I've seen over these years, and now how you can use the same thing on your tool of choice, because OpenTelemetry and open standards are there. Whether you're using Jaeger, whether you're using Honeycomb, Datadog, Dynatrace, I don't care. But I want to show you some of the things you can do. Now, what I've noticed, this is one of my favorite examples, and it was one from my friend Robert. So Robert is a software engineer that I used to work with in the previous company, and then he built an e-commerce solution for one of the local companies in Austria. Everything worked well when the e-commerce store was very small, had not many products, but all of a sudden when it grew, he ran into a data-driven problem. What you see here is a single request that starts on the front end, and all of these things here are database queries that are executed for a single search. So he implemented a search feature that searches the product catalog, and the way he initially implemented this, he did a query to say, what are all the product categories? And then he was fetching all the products of every category with a single query. And as the product catalog grew, he ended up in a search with 26,000 database calls. And the reason why I bring this up, this probably sounds stupid. You said, this cannot happen to us. I am pretty sure a pattern like this is in your environment, because I see it still every day. Another one, as we have migrated from monoliths to microservices, I see a lot of organizations ripping apart their code. And what used to be a single call to a quote service started in the front end, all of a sudden made multiple different calls to these backend services. And every call, and this is an example from one of our customers that I work with, every call, well, first of all, it's many different calls that you now have to factor in, right? Network traffic, round trips, and all this stuff. For me, the interesting thing is, though, because the way they extracted the microservice, every microservice had to make the same 2 or 3 database calls to get certain information that was previously done in the monolith. Right? And I know you're smiling because you see this probably as well, right? This is, of course, all the time. Yeah. And this is a simple example. I have another one. This was just recently shared by me from one of our customers in the US. And I said, I want to show a really cool trace. And the trace starts really small, and it goes down, and it goes down, and it goes down. Right? So this is also just a single lookup of a record in the database. It's a car rental company, very large car rental company in the US. And you can see how complex these things can become. And the reason why all of this is so complex, because many people have worked on this code. Many things have been refactored over the years. And all of a sudden you have recursive calls, you have duplicated calls. So there's a lot of these patterns out there. In my career, I had at one time where I offered a program. It's called Share Your PurePath. So PurePath was our name for our distributed traces, and people could send me their traces, and I analyzed it for them, and I sent them back what I found. And so I had over 1,000 people that sent me their traces over a period of 2 or 3 years. And then I wrote a lot of blog posts around it. A couple of interesting ones that are here, right? Classical are connection pool sizes, top exceptions, exception flooding, log flood, so excessive logging, the same log multiple times. Also, if what I've noticed, quick question, I would assume all of you have logs somewhere, right? Logs. You probably have exceptions in your logs. If you now start tracing, the trace will also contain the exception. That means you get the exception in the trace and you get the exception in the log. So you get a lot of duplicated information. These are some of the patterns you want to care about and look out for, because these are not good observability best practices. What else do I have? Well, there's many more of these examples. I had many talks over the years, so instead of boring you with many more of my slides on samples, this was one of my talks at DevFox in Poland. It's all on YouTube, so this is where I go through about 5 or 10 more examples if you want to. So this was my career started in 2008 in tracing. 2019 was a pivotal moment because OpenTelemetry came into the picture, and I know there's a lot of people that have probably done talks yesterday. I wasn't here yesterday, but I heard that a lot of people have introduced OpenTelemetry. So I will not go into too much detail, but what I think is OpenTelemetry really boosted distributed tracing in our community. There's so many different tools out there now that you can use to analyze your traces, and I know that these logos are not complete. So I'm sure there's many other tools that I don't even know about. There's new vendors coming up every day. Thanks to OpenTelemetry, thanks to technologies like eBPF, we now get easier ways to extract traces, logs, and metrics. And I think you talked me about this earlier. When we talked, you have a session this afternoon also about observability, right? Yeah, you told me that there's a lot of introduction has already been done, so I keep it short. For those of you that have never seen traces, right, there's different tools that you can use, whether it's Jaeger and how they are visualizing traces. I think this is a very common tree-based structure where you can see the trace. Grafana does a great job in visualizing the service flow, where you can see which services are called, where are your hotspots. And what I also love about this, is anybody here using GitHub by any chance? Yeah, sometimes, right? Servus, Robert. This is another Robert. Were you in here when I started talking about the Robert story? Baminger Robert. Yeah. So another cool thing with OpenTelemetry, one of my colleagues, he open sourced a project that automatically instruments bash scripts with OpenTelemetry, and then he extended it to GitHub Actions and GitHub Workflows. So you can now get an end-to-end trace for every single GitHub workflow down to the bash scripts that you call from your GitHub Actions, which is pretty cool. Open source, try it out. We have a video that we also put on YouTube. Great work. So what I'm saying is these open standards also inspire new cool ideas. Right? All right, I know in the very beginning some people raised their hands and said they've never seen a trace, they've never done it, so I need to cover a couple of basics. If you look at a trace, an end-to-end trace from a terminology perspective, right, from left to right, we have what we call spans. Spans are the individual nodes that we have on there. A span has an ID, a span also has a parent span ID, so we know how all these things link together. When we have calls in a distributed system from one service to another service, right, we call them requests, so everything that happens in a service, and then the full end-to-end thing is the real trace. So if you think about requesting something on your web server until it goes through all the microservices to the database, there's a lot of individual nodes. Everything within a service is what we consider a request, because if you're a service owner, you want to know what's happening within your service. And then the whole thing is an end-to-end trace. Okay? There's also a lot of information stored on every of these nodes. All of this is standardized. There's semantic conventions in the community so that we make sure that what data gets collected, there's certain metadata with certain names that we can count on. Because then we can also, we as vendors and tool developers, we know what data we can expect when this is a database node, when it's a queue node, and so on and so forth. There's also, obviously, right, these individual nodes can represent different calls here, right? This could be a Lambda invocation, an internal method call. A node could contain an exception. It could be a call putting a message into a queue. It can be database calls. These are really representing whatever your code does and whatever you decide to also trace. Okay. One last thing that is important on the basics, request routes. So I talked about the whole thing is a trace, and everything is a request on each service. And every time a trace continues in the next service, the first node is considered the request route. And it's also marked particularly. Okay. And just to show you how this looks like, let's see if this works. Remember the slides that I highlighted, the links. So this is a public environment, so that you don't need to buy Dynatrace, you don't need to do anything, but you can, with the links that I gave you earlier, you can sign up for the accessing the playground tenant, and then everything I show you today, you can do the same thing. But feel free, obviously, to do this with your own tool of choice. What I'm showing you today are examples against the AstroShop OpenTelemetry demo app, which is the app that is used widely. But if you're opening up the link that I gave you earlier, you have example queries, the links to our different apps in Dynatrace, the link to the slides. And in here, I have all of these different queries that tell me patterns that I'm interested in, right? So for instance, top exceptions over time. I can read and I can extract exception information from my spans, and I can see after deployment, after configuration change, all of a sudden I have a certain exception going through the roof. I can also then link it back to which endpoints, which service version, right? I can do all this. So all of this is here. I also want to quickly show you how you typically analyze distributed traces, right? So we have what we call a distributed traces app, where I immediately get an overview of what's my response time over time. I can also do, I'm a performance engineer by heart. I really like analyzing traces based on different performance buckets. Right? I don't want to analyze the average one, I want to analyze the outliers. So you can immediately then see, kind of zooming in and then trying to figure out what are these spans here that are taking that long. You get all the overview, right? They are all coming in from OpenTelemetry here. I can click on any one of those, and then I get to the full end-to-end trace as I showed you earlier. And remember, what are these individual ones called? What is a line here? Span, perfect. What are all the ones that are in green here? Request, yeah, exactly. It's a request in a service, and the whole thing is an end-to-end trace. And everything, when I click through it on the right side, this is all the metadata that is on that span. There's a lot of data on here. Right? And I think I had one here from, it's basically very similar, right? You can see some of these, this is all from the OpenTelemetry demo app. Some of these requests are really, really big. This is actually one that includes both OpenTelemetry traces and traces that come in from our agent. So the beauty of an open standard is you can also combine different technologies on how you instrument data. Right? So some of these nodes here, some of these spans come from OTel, some come from the agent. Cool. All right. So let's see where I left off. Good. We did this, the anatomy. Yeah, remember all the slides and all the patterns and the notebook that I've just shown you are available for you as well. All is public. The patterns that I talked about, I want to just pick a couple because those that are dear to my heart, but the full slide deck contains examples of all of these patterns. So how do I detect, for instance, HTTP requests that are not only taking long, but that have unusual large request bodies and response bodies? How do I detect traces that have excessive logging, duplicated logs, logs where you have the same information in the log, but also already on the span, like the exception that I mentioned earlier? Because if you're looking at this data, why do you capture things duplicated? The classical N+1 query problem, and so on and so forth. I also try in all of my slides to give you first a visual representation. Right? So these are 3, for instance, end-to-end traces. And if you're interested in analyzing what is the traffic on my root endpoints, give me an overview of how many requests are coming in at the very front. What have we learned? We need to basically run a query against the service we're interested in. So only look at the traces on the front end in this case, where we have the root node information on it, and then you can calculate all of your statistics, right? As I said, I'm a big fan of performance engineering. I typically don't look at averages only. You want to look at your percentiles. You also want to look at outliers. You want to look into if individual requests have extreme outliers, right? The same endpoint, but huge variation. Then something is fishy. Something is wrong. Okay. So this would be, and I know I'm always showing our query language, but your tool may have a different query language or a different way to get to the data. In our case, it's fetch spans. So give me all the spans, filter on a particular service that I'm interested in, only look at those where the root span is set to true, and then give me an overall count, and then also a count of the duration, the minimum, the average, the percentiles. And I'm pretty sure whatever tool you use, I assume you can do something similar. Okay? And the same would then also work if you do it, for instance, for all of your services. So in this case, similar query, but instead of saying I'm only focusing on one particular service, I'm interested in all the service end to end, then you can run the same query, and then you can really see what is the performance distribution. Make sense? Yeah. Cool. Oh yeah, now this is a good one for me. I've seen so many applications not doing a proper job in cleaning up the request responses, right? Like extremely large response bodies for whatever reasons. If you have HTTP requests, you have the information on those requests, how big that request body size and the response body size is. And if we have this information on the span, we can also say, look at all of my spans and give me an overview of the largest requests. And also again, if the same URL has a huge variance, then something is also interesting. Could be, because as designed, if you have a report generator that generates small and larger reports, but these are some of the things that make sense to analyze. Okay, jumping quickly on, I want to do some database examples. SQLs, here we go. If we have traces and in the very back we have database calls, what can we do? We can say, look at all the spans where we have database information on it. So there's metadata. It's called the DB query text, for instance. And then I can run a query and I can analyze, give me the top SQL statements that are executed. Again, how often they're executed, what is the min, the average, the max, the percentiles. I also have here, my eyes are already getting really bad. I think the last column talks about the difference of execution times to the average. So analyze it. Also over time, if you have this data, you can also chart it over time, and you can figure out what are the top SQL statements that are being executed. You have amazing data in your pocket. You just need to use it wisely. Yeah? biggest variance in SQL execution time. If the same statement executes in 1 milliseconds, but the same one also takes 5 seconds to execute, then I wonder what's wrong. How is this possible? So here I have a table. I think on the bottom, this is the one that I meant. So on the top, you see the same SQL was called multiple times. I saw that, and I see there's a huge variance. So on the bottom, I just say, okay, go through all of my spans and group it by the SQL statement, and then give me min, average, max, and the difference between average and max, so you can see really your outliers. Then we wonder why that is. Okay. Good. So a lot of other examples on databases. I glance over this quickly, even though this is a cool one. Some of the OpenTelemetry instrumentation libraries also capture the number of affected rows. So if you have a SQL statement, how many rows came back from a select, how many were inserted, updated, or deleted? And if we have this information on the span, we can say, give me an overview of the top SQL statements and the amount of records that they're impacting. And so here you can see there's one standing out. One of those queries is always returning about 10,000 rows. Make sense? Yeah. Cool. Awesome. What else do we have? I'm jumping a little bit ahead. I want to do exception analysis. Exception analysis for me is really important because on some of those nodes, actually let me go back. I think I have an example here. If you look at nodes that have an exception in OpenTelemetry, exceptions are captured as a so-called span event. And it's actually the span event is an array because you can have multiple exceptions on a node. So this is how the raw data looks like in OpenTelemetry. And what we can now do is we can again run a query and say, look at all the spans where we have span events that mark an exception, and then give me an overview of what are the top exceptions and also in which particular service do they come in. Right? And then we can also do the analysis over time. Right? Obviously, something clearly happened here because at this particular time frame, we had a huge spike in just a couple of those exceptions. And if I'm interested in exactly those, then I can also filter and I say, hey, only show me those errors, and then show me not only the exception type, but show me the actual exception that happened. Okay? Good. How am I doing on time? 10 minutes, okay. One thing, the last pattern here that I want to show you on traces, then I want to go to logs, is every trace is different, right? Some traces are 5 nodes long, and you saw the earlier one from the car rental company, hundreds of the nodes long. So what I'm also always interested in is looking at the complexity. How deep is your trace? And I guess we can make a song. How deep is your trace? But what we can do is because every trace here has one unique identifier. That's the trace ID. So we can run a query where we can say, I want to count the number. I want to get an overview from every trace ID. I want to know how many spans are in there and also how many clients and server-side calls are in there. Because then I know how complex some of these are. And then you may wonder, right? Why do we have individual ones that have 50, 60, 100 different service calls? And you can go even further. What I've seen is when you have an environment and you make misconfigurations, and all of a sudden your development environment talks to your production database. So you can actually say, show me all the traces where we have a call to a service in a different environment. Right? Super easy. And if you have the trace ID, right, with the trace ID, like the one on the top with 90 spans, you can then just open up that particular trace because the trace ID uniquely identifies that trace, and then in your tracing tool, in your analytics tool, you just jump to it, and then you can analyze it. Okay. Cool. All right. Last pattern I have to. This is another one that I need to quickly cover. I know I'm promising it's the last one, but and you cannot escape because you're in the middle of the row. one of the things that I've seen is if you have a transaction, sometimes you want to know how much time of that transaction is actually spent in a certain area. Classical one is how much time is spent in the database. So what I'm interested in is how much time do we take overall, if you have a certain budget, and how much time is happening back there. And we can again calculate this. So what is the time spent in the front end versus in the back end? What is the time spent in the front end versus the database calls? And if that time all of a sudden shifts, then something might be wrong. Maybe the database is outdated. Maybe database indexes need to be updated. Right? So these are some of the things. And to give you an example, I think, are you all familiar with XXX, the company? XXX, yeah. I'll show you what they do with traces. They have, what you see on the top left, it says hot deals search DB percentage. They are using trace-based analytics to figure out how much time in their hot deal search is spent in the front end versus in the database. And because their architects know the time in the database should not be more than 5%. If it's more than 5%, something is wrong. And historically, they know typically what is wrong. Somebody from XXX was uploading 1,000 new chairs, 1,000 new tables to the product catalog, but didn't tell the DBAs about it to update their indexes. So what they are doing, they have a lot of these time in the database, time in the front end, time in the proxy, and they are defining these queries. And then what on the right side you see, they are integrating this in two areas. Once in the CI/CD, so every time they have a new build, they actually validate, are we still doing what we expect? But also live in production, every 15 minutes they just say, show me that metric, but not only the one, but all these 20 and 30, and give me an early warning indicator, because if the database percentage goes up over a certain threshold, we need to run now, and don't wait until our web shop breaks. Okay, good. This was a lot about traces. Quickly, what about logs? Log patterns that I see constantly: excessive logging, no good log level set. So you can see here, 34,000 logs with no log level. Right? That's not a good thing. You should think about it. Your log levels. So get an overview, also your heavy hitters, who are your top log sources, where do these logs come in? Another use case is if you're looking at traces and if you enrich your logs with the trace context. So there's two logs here, right? One log has the trace ID. That means we can correlate it with the trace. The other one is also a very important log message, but it doesn't have the context. So we cannot correlate them. And one of the things that I always try to do is I try to figure out how many logs do we have from a particular component that are associated with a trace and how many not. So what's the log trace percentage? Because if you enable a new service with traces, but you still have 90% of logs coming in that are not connected to a trace, then maybe you're missing some good entry points. Okay. And also the top log producers, that's also always interesting. So give me a list of all of the URLs, my top URLs, and then show me how many logs are coming in and what is the log per request ratio. So how many logs are generated per request. And it seems the top one, the send order confirmation, is called 267 times in that time frame that I analyzed. I have 7,400 logs. That means on average I produce 27 log lines for this particular endpoint. Okay. Awesome. Last piece of advice before we go into Q&A. Spans and logs are great, but they can become very expensive. Right? Because if you're analyzing millions and trillions of spans, because you're analyzing 10 days worth of spans, and you have a high volume environment, then you actually need to scan your tool, whatever tool of choice, needs to scan a lot of data. Therefore, the best practice is, for instance, my exception example from earlier, in order to analyze 24 hours worth of spans on the AstroShop app, I had to analyze 12 gigabytes of spans to get an answer that I probably want anyway. So therefore, think about, you can use your OpenTelemetry collector to extract metrics from logs, also your OpenTelemetry backend solution, whatever you use, Datadog, New Relic, Dynatrace, they all allow you to also extract metrics from traces. If you already know that, hey, I'm interested in how many exceptions are coming in, how many database calls are coming in, then you can convert it into a metric, and a metric is much cheaper to query than always having to go through all the spans. Perfect. Good. I got 5 minutes left, which means I want to say thank you. Follow up with me if you can on LinkedIn. Also remember the links that I showed you earlier. And yeah, hopefully this gave you some new ideas. We have an awesome data at our hands. We just need to put it to good use. And with this, some Q&A. So the first question is, what sampling should be used to make this analysis and are relevant? Yeah, sampling is a big discussion, obviously. Head-based sampling, tail-based sampling. We typically sample out. Who asked the question? Yeah. So the first thing what I see is get rid of all of the irrelevant endpoints. There's so many irrelevant endpoints, or put a higher sampling rate on it. Now there's a big discussion about head-based sampling and tail-based. Sounds really cool on paper, but it's very expensive because tail-based sampling, deciding at the end of the trace, means you need to first capture the whole trace in one environment, in one big OpenTelemetry collector, to make then a decision. Right? It is possible, but be aware of the cost. We have, from a Dynatrace side, we have a documentation page. We call it Adaptive Load Reduction, where we are actually documenting over the last 20 years, since we have been doing tracing and sampling, how we do it. Right? So there's certain lessons learned on where we throw things away. What you never should throw away is the sampling ratio. So for instance, OpenTelemetry right now doesn't capture the ratio of sampling. So if you turn on sampling, let's say 10%, the trace in the backend that ends up, let's say, in your backend solution does not know that this only represents 10%. So you can never extrapolate. So think about this, that you need to enrich your traces also with the sample rate so you can extrapolate the data, because otherwise you don't know what the real data is. Yeah. How do you connect leaf spans of services A to root spans of services B baggage? Exactly. So for HTTP requests, it's typically the trace gets added as an HTTP header. There's also an open standard called the W3C trace context. For JMS and for messaging systems, it's typically a property. There's some way you need to put that trace ID on that message that then gets picked up on the other side. And again, for OpenTelemetry, there's a lot of instrumentation already available that they also do it. And also for all of the commercial solutions, we have been doing this for 20 years, and we just add it to the message. Yeah, typically.
Cool. That's all from Slido. Any question in the audience? Yeah, come on.
I have a question about converting exceptions to metrics. Aren't we losing the body of exception, and this way we're losing ability to do full text search on some parts of?
True, you always have to have the trade-off. Exactly. And I'm not saying that you should throw everything away, but what I'm saying is you can still keep it, but as a first analytics, as a first thing, I would look at the metric chart and say, does everything look okay? Oh no, yesterday at 1 o'clock, I had a spike. I can do this on metrics. If I now want to zoom in into this 1 o'clock time frame, I can still go to my traces if I have them. What I was telling you is if you're always looking at a 24-hour graph and it's based purely on analyzing spans, you always have to dig through 12 gigabytes of data every time you open up that graph. So that means extract a metric to get a nice trend overview and then zoom into that time frame, and then you can do still your detailed analysis.
In logs, or we just removed logs?
No, what I'm saying is you're extracting additional metrics. So if I look, I'm not on the screen anymore. Okay, I'm back. So if I look at my at my thing here, right? I still have all the data, but when I do my quick analysis, I don't need to generate this graph every time by having, in this case, Dynatrace analyze 12 gigabytes of data. I can say I'm additionally extracting a metric, and on a dashboard or stuff that I use for alerting, if we have an anomaly, I use a metric. A metric is much cheaper in any observability platform, right? And then I can say, all right, now I know where the outlier is, and now I do the analytics. Now I take this time frame, right? I zoom in, I take this time frame, and then go into my traces, where I still have all of my detailed data.
Oh, okay. I
Okay.
see.
But there's also, I think, certain reasons where you would also think about, do we really need to store every single exception? If we have 5 million of them and they're all the same, do I really need to capture and maintain and store it? Right?
Yeah.
Yeah, but thanks for the clarifying question. That was good. Yeah.